Today I want to talk about the Roomba example, which we saw in the labs. Now, it's been a little while since I've looked at this example, so three very diligent students came to see me the other morning during my office hours, and I was woefully unprepared, unfortunately, to talk them through it. So what I've done is I've gone away, I've looked over the example, and I'm now going to program it from scratch. So thanks to the diligence of those three students, you know who you are, hopefully you'll all get to benefit. Okay, so I'm just going to run through not all the questions, but a majority of them, and I'm going to think about how we could construct a solution to these questions. Okay, now there's nothing new here, nothing new. It's just applying concepts that we already know, concepts we've seen from the noughts and crosses example, concepts you've seen in the coursework. So it's nothing new, it's just applying these to a larger example. Okay. So I fear this video might be quite long, so hopefully now you're seeing on your screen I've put a list of times so you can skip through to relevant parts, particularly those parts that you're struggling with in your own work. Okay. So let's crack on. Let's look at the first requirement. So as always, we look at this sheet of requirements and it tells us what to do. Remember, the requirements in labs are always more specific than they will be in the coursework, so let's work through this step by step. So the first one says, define an object that represents a Roomba. It should record its position as an XY coordinate relative to some origin and its size. Okay. Now, this relative to some origin might seem a little bit unclear. Well, basically all this is saying is you have to set up your own coordinate system. So you need to decide on an X and Y landscape, and you need to decide where this starts. So perhaps you might, for whatever reason, want your X and your Y to be negative. But in this case, I'm going to assume that my origin starts down here in the bottom left-hand corner. And as I move right, then obviously my X value increases. And as I move up, then my Y value increases. Okay, so a Roomba has a position which is an XY coordinate, and it will look a little bit something like this. So the Roomba will be on this plane, and its position will be defined by the center point of a circle. Because of course Roombas, as I'm sure you're aware, these little robots that can vacuum rooms. They are circular. So we're going to record the position of our Roomba based upon the very center of that circle. Okay, so the position of the center of this circle is the location of the Roomba. Okay, so in this example, these aren't necessarily real coordinates. I've just typed these in quickly. The position of the Roomba on the x-axis is 5.2, and the position of the Roomba on the y-axis is 4.8. Okay, so this fulfills our second requirement that says Roombas are not necessarily, they don't just necessarily occupy integer value locations. Okay, so at the end here it says Roombas do not necessarily occupy only integer value locations. So we're accounting for that. We're gonna actually record not just these integer values. We're going to have degrees of location. Okay, which will suggest something about the type of variable that we're going to use to record the coordinate. And we'll look at that in a moment. Okay, so we want to define an object that represents a Roomba, recording the x and y, and its size. Okay, so by size, what we're going to use is the Roomba's radius. Okay, so we're going to refer to a Roomba's size by looking at its radius, which is obviously the distance from the center to the edge of the Roomba. Okay, so we're going to record a Roomba's size according to its radius, and as we develop our solution, we'll see why this is important for the calculations that we need to make in the future. Okay. Now, importantly, this class will not have a main method and should contain no static components. So what this means is there's going to be no main method when we represent a Roomba, but instead what I'm going to create is this extra class called Gwyneth. This is obviously, the scenario here is about Gwyneth Paltrow, and inside this class, this is where my main method is going to be. Okay, so as we know, when we don't have a main method in a class, that means that objects of that class are going to be made elsewhere. Okay, and that place is inside the main method that I'm going to have inside the Gwyneth class here. Okay, so no main method inside Roomba, no static components, just a class that can have objects made of it at some point in the future. Okay, so it's just a template for objects that are going to be used at some point in the future. So in this case, inside my Gwyneth class, inside the main method. Okay. So we can start. So let's define a Roomba. Let's think about what we need. So we need obviously an X position for the X coordinate. We need a Y position for the Y coordinate, and we need a radius. Now it would be fine to represent this X, Y coordinate as maybe a separate class if you wanted to, which would be very simple. It would be a class called maybe coordinate that returned an X and a Y. But for now, just for simplicity, I'm just going to define these as two separate fields. Okay, so we're going to go private double XPOS. Okay, so now remember, double provides me with access to these decimal values. Okay, so the requirement says that Roombas do not only occupy integer value locations. Okay, so this implies that they're going to occupy decimal value locations. So we're going to have our X position as a double. We're also going to have therefore our Y position as a double. And obviously, therefore, because of these two things, it makes sense also to have our radius as a double. So 3 fields here, which are going to store information about our Roomba. Okay, so I'm not going to go into too much detail here about the fundamental object-oriented principles. There are other videos on this, so the noughts and crosses example and the superheroes example. These 2 videos go into lots of depth about how fields work, how methods work, what constructors are, and all these kind of things. Okay, so I'm going to assume a basic level of knowledge in this video, which is that you've watched these videos and you're comfortable with what fields are, what their purpose is, why they're private, for example, and the whole idea of what happens when we make an object of a class, okay, which is that we take a copy of the code. So at any point, if any of this doesn't make sense, go back to those videos, use them as a starting point. But here, as I say, I'm going to assume some kind of basic understanding. Okay, so we've got an X position, we've got a Y position, and we've got a radius. Okay, so we've defined this object and we've defined a place in which we can store this information. Okay. The next part of the requirement says the class should offer a constructor that allows the user to specify the initial location and size. Okay, so we're familiar with constructors now, no return type, have to have the same name as the class. And what we're going to do is we're going to say this constructor accepts 3 pieces of information, the XPOS, the YPOS, and the radius. Okay. Ooh, spelling. Obviously now we're going to assign this to the field value, so when I input information into my constructor I need to store that information somewhere to make the class useful. Again, I'm going to use the this keyword. Remember, there's absolutely no requirement for you to do this. You could have different values in for the arguments, different names for the arguments if you wanted to, but here I'm just going to, for neatness, for my own coding preference, I am going to use the this command. Okay. So we've created a constructor, we've created a place in which we can input these values and store them. Okay, so the class should offer a constructor that allows the user to specify the initial location and size. So obviously this is saying every time I make a Roomba object, I have to give it the X position, the Y position, and the radius. Okay, so let's do a little example. So as always, I've got my little cheat sheet open. So every so often you're going to see some copying and pasting, some magic, and this is me just adding extra things in for brevity so that you don't have a 5-hour video. Okay, so ta-da, we can make a new Roomba object. We could call it SuperVac, I guess, but it might make more sense to call it Roomba for this. So we're going to create a new Roomba object. We're giving it the information it needs. It needs an X position, a Y position, and a radius. So we're going to say it's one unit along, 1 unit high, and the radius is 25. Okay, so new Roomba object here. Very simple here. This should be something that's extremely familiar to you now. So just a copy of the Roomba class where we've initialized these variables, these fields to contain certain values. Okay. Next requirement, it should also be possible to specify a new location for the Roomba. Okay. Again, very, very simple. All we need to do is we need to provide an extra method. This time we're going to call it move to. And what this is going to do is it's going to take a new X position and a new Y position. We could actually call this something like new XPOS and new YPOS. And all this is going to allow us to do is it's going to allow us to change the values inside the fields. Okay, so this dot XPOS equals new XPOS. This dot YPOS equals new YPOS. Okay, what this allows us to do is to update the existing values. Okay, so if we effectively want to move our Roomba through this 2D space, then we're going to need to change the X and the Y values, aren't we? So we're going to need to change them at the same time, which will give our Roomba a new location. Okay, so we're going to, if we want to move our Roomba, if we want to model the capabilities to move a Roomba, we need to have this method which accepts a new x position and a new y position and updates the location accordingly. Okay, so we're storing information about the position of our Roomba initially, and then we want to have the ability to update that information. Okay, this should be all very straightforward so far. Again, if any of this doesn't make sense, if it's not clear what any of this syntax means or how I'm making a copy of the code here, go back and watch the previous videos before watching this one. Okay. Next requirement, finally define a toString method that returns a suitable string which forms the current position of the Roomba. Okay, so this should be very, very familiar to you now, especially after the second piece of coursework where we had to use a toString to return the name of a superhero. Here instead, what we want to say is when I print a Roomba, so if I do something like system.out.println Roomba, then I don't want the memory address location, I want to know some useful information about the Roomba. Okay, so what I'm going to do is I'm going to define a toString method. This should be quite familiar to you now, so public string toString. Okay, and I'm not going to do something like return just the x position or just the y position. Remember, I can return really anything that I like so long as it's an appropriate string. What I'm going to return is a concatenated string, okay, a little bit more pasting magic. So what I'm going to say is I'm going to give some useful information to whoever is printing my Roomba object. I'm going to tell them the Roomba radius. Remember, the plus here is concatenation, so it combines individual objects and turns them all into a string. So the result of adding all these things together is one complete string, which I can then return from the toString method, and it will be output every time I print this object or an object of this class. Okay, so every time I print the Roomba, it's going to say the Roomba radius, which is going to be whatever value is in the radius field. It's going to tell me where, and then it's going to tell me where it is on the plane, so at its x position and its y position. Okay, we can hopefully see this running very briefly. So if I run this, then it tells me Roomba radius 0.25, and we know it's at position 1, 1. Okay, so this is the exact information that we gave here. And if we were to do something like Roomba .move to, I could give it a new position, say 2, 2, like that. I could run my code again, and you see that it's now moved position. Okay, so this was very similar to power up, if you remember. So a superhero object had one state, which was a certain level of power, and you were able to access that state and see the result of a fight. Then you were able to power up that object or that superhero, so you were able to update that state, and then you were able to print the new result of the power up or the new state. Okay, so object orientation is all about objects that have state. Okay, so state is literally just the values inside fields. Okay, so you should be able to update that state and get new information back. Okay, so for example, when I first make my Roomba object, the state of that object are the values 1 and 1 in the x and the y fields, and the radius is 0.25. But then I can update this state to instead have the values 2 and 2 inside the x position, inside the x field, and the y field. Note here that I'm only inputting integers inside here. I didn't feel in this case that I wanted to specify a Roomba being at a decimal location, but note that the actual values I get out are put into decimal. Okay, so when you're well within your right to assign an integer value to a double field, and what Java will automatically do is add the extra precision on for you here. Okay, so it will add the 0.0 on the end. It will effectively transform the integer into a double. Obviously, you couldn't do that the other way around because Java would preempt the fact that you might lose information. So, for example, if these were integer fields and I wanted to enter something like location 2.5, then that would not be allowed because Java would be unable to store the necessary precision. You would receive an error for that. Okay. So that's toString setup. We know when we print an object of this class, I'm going to see all the relevant information, and that is in fact the very basic form of Roomba done for now, which is good. Okay, making good progress. The next requirement asks you to build a new class, which is going to be called Roomba Moves. Okay, this is in the requirement. It says this is going to be a very simple class, and that's correct. So what a Roomba move is it represents a potential move that a Roomba might make. Okay, so again, I know that inside the noughts and crosses coursework, some people disagreed with this idea that moves should be represented as a class. But here I think, again, it makes sense because there is some state to a move. There's an X and a Y position, and we need to record this state. So let's look at Roomba move. We can open this up. I have a class that I've already prepared. So let's look at Roomba move. Let's look at the information that we need to store. So it simply is a case of recording the X and the Y move. It makes sense to have a constructor which will ensure that every move consists of an X and a Y move, and then to have some way of getting this information back. Okay, so have some way of finding out which X and which Y are contained inside a move. Okay, so very simply, we're going to have a private double X move. Oh, definitely not movie. X move. We're going to have a private double Y move. Okay, and we're going to have a public Roomba move. Have a double X move and a double Y move. Okay. Again, we're going to assign these values to the fields using the list command, so I can keep things neat. Again, if you'd prefer to have different names in your parameters, that's fine. So now we've said that every move has to have an X value and a Y value. We've assigned these values to the fields. Now we're going to provide some simple methods, getter methods, which are simply methods that are going to return some value stored inside our class. So get Y, return Y move. Okay, and that is it. Okay, so all we've got here is one of the most simple classes you could have, which is effectively just a special data type. Okay, this is just a special data type that's going to contain two pieces of information, which is a move in the X in the X position and a move in the Y position along the Y plane. Okay, so we use a constructor to enforce that these values have to be input, and then we provide some way of getting this information back. Okay, so these are called getter methods. These are methods which their sole function is to return some value back from an object. So when I call getX on an object, on a Roomba move object, it's simply going to return me the current value inside the X move field, and the same for getY. Okay, this is very similar to the move class that we did for noughts and crosses. Okay, very simple indeed. So simple, in fact, that we're going to move along. We're going to look at the next requirement, which asks us to create a class that represents a piece of furniture. Okay, so we don't just have these little Roombas in our room, we don't just have these little hoovering robots, we also actually have pieces of furniture, as you would expect in a room. And the idea is that we don't want the Roomba to collide with this furniture. Okay, so that's our overall aim. We want to work out how a Roomba will move through a room, and we want to make sure that there are no collisions. Okay, so that's our overall aim. So what our requirement asks us to do is to create a class that represents a piece of furniture. Okay, and it asks us initially what information should be recorded and what methods should be supported. Okay, and we're told that there are actually two key pieces of information that we need to know about our piece of furniture. We need to know how big it is, so its length and its width, and we need to know where it is in the room. Okay, so this suggests it's got an X position and it's got a Y position. Okay, so to save time, I've actually already entered in the information in the format that we're used to. So in the same way that we recorded the X position and the Y position for the Roomba, we're going to record the X position and the Y position for the furniture. And while a Roomba just had a radius, a piece of furniture is going to have a length and a width. Okay, so then we have the normal constructor with an X position, with a Y position, a length and a width, which is going to ensure that every piece of furniture has this information. Okay, this should be really familiar by now. You should be more than comfortable creating fields and creating constructors that set values to these fields. Okay. While it was quite intuitive that we would measure the X position and the Y position of the Roomba based upon the center location of the vacuum, it's less obvious how we'd measure the X position and the Y position of a piece of furniture. Okay. So what I'm going to propose is that we don't actually measure the center of a piece of furniture. What we're going to measure instead is actually the position of the bottom left-hand corner. Okay. Now the reason for this will become clear momentarily. What this actually will allow us to do is to examine the location of all the corners. Okay, so we need some way of finding the location, the X and the Y position of all the corners, because we need to think about situations in which the Roomba might collide with either one of these corners, or the situation in which two pieces of furniture might, for whatever reason, collide. So we need to find some way to return the X and the Y position of each of these corners. But at first, we're going to just base our X and Y position on the bottom left-hand corner. Okay? So building on this idea, let's imagine that we have a numbering system to our corners. So the bottom left-hand corner, our first corner, so to speak, with the original X and the Y position, we're going to call corner 0. And then going around in a clockwise motion, we're going to call the top left-hand corner, corner 1, the top right-hand corner, corner 2, and the final bottom right-hand corner, corner 3. Okay? So we want to provide some way of getting this information back, getting this information or storing this information about a piece of furniture based upon a supplied corner. Okay, so we're going to do something like this. We're going to add a method called get xpos, okay, which is going to provide us with the x position of a given corner. Okay, so we're going to say get xpos. This is going to provide us with the x position of a given corner. So I want some method where I can supply the number of a corner, so 0, 1, 2, or 3, and I'm going to be able to understand, therefore, which x value this corner contains. Okay, so how far along the x-axis this corner is. Okay. So given that we're measuring from the bottom left-hand corner, hopefully it's intuitive that corners 0 and 1 are on the same x level. They're at the same distance along the x-axis. Okay. So what I'm going to say is if the corner supplied to the method is equal to 0, or the corner supplied to the x method is equal to 1, then I'm simply going to return the x position. Okay, so remember, we're always basing this upon the bottom left-hand corner. So if someone wants to find out the x position of the bottom left-hand corner or the top left-hand corner, then we know that these are the same distance along the x-axis. So I can simply return the x position, which remember refers to the bottom left-hand corner. Okay. Otherwise, they're going to be referring to corners 2 or 3. Yeah, so they're going to be returning to corners 2 or 3. Then the only way I can find the x position of corners 2 or 3 is to not just return the x position by itself, but to return the x position plus the width of the object. Okay, so if I want to find how far along the x-axis corners 2 and 3 are, I not only need to consider the x position of my origin, in this case the furniture's origin at least, corner 0, I need to consider that plus the width. Okay, so if I want to find out how far along the x-axis corners 2 and 3 are of a given piece of furniture, I need to return the x position plus the width. Okay, so what this method neatly allows me to do is to understand the x position of each corner of my piece of furniture. Okay, so I'm providing a really detailed way to understand exactly where a piece of furniture is. Okay. Hopefully you can see that the procedure for the y position is very, very similar. So again, working on the idea that the x value, the x pos and the y pos refer to the bottom left-hand corner, I could do something like public double get y pos. I'd supply a corner as such. And this time I don't say if corner is equal to 0 or 1, I actually say if corner is equal to 0 or 3, okay? Because corners 0 and 3 are on the same distance along the y-axis. Okay, so assuming that we're measuring y as we did x from the bottom left-hand corner, then I know that 0 and 3 are the same distance along the y-axis. So I can say if corner equal to 0 or corner equal to 3, then I want to return the y position. Okay, so I know that both these corners are the same distance along the y-axis, so I just want to return the y position. In any other situation, yeah, so in which case is if I want to access corners 1 or 2, then I know in exactly the same way that I had to add something on to the x position, in this case the width, in order to find the position of those corners. In this case, I need to add the length on, don't I? So y pos plus length. Okay, so if I want to find the location of corners 1 and 2, their y location, then obviously knowing the y location of 0 isn't enough, because obviously corners 1 and 2 are higher up than corners 0 and 3. So I need to add the length on. So if I want to find the y position of corners 1 or 2, then I need to add the length on to those values. Okay, so this is quite subtle. but this is a nice and it's a neat way to understand exactly where our piece of furniture is in the room. Okay. So that's furniture done for now. That's furniture completed for now. We've got this way of getting a really detailed understanding of where a piece of furniture is. Okay. So now as I've talked about before, we've now modelled our piece of furniture, we've now modelled our Roomba, and we now want to think about the situation in which the Roomba may collide with a piece of furniture. Okay, so we want to understand, given a potential move, so for example, if the Roomba plans to move into a certain X and a certain Y location inside the room, we want to know that when it's at the X and Y position, will it collide with a given piece of furniture? Okay, will a collision occur? Okay. So what this asks us to do in order to achieve this is to extend our Roomba class to include a method called collision. And what this method is going to accept is two pieces of information. One is an object of type Roomba move, which we know contains nice information about a potential move. And one is an object of the type furniture, which we've just created. Okay. So we can go back inside Roomba and we can add this method in. Okay. So we can say public Boolean. Remember, we want a true or false value back from this method. We want to know, has a collision occurred? Okay, so we're going to assume that this question is asking us to implement the functionality in which if a collision has occurred, then we return true. And indeed it says this here. So this method will return true if the Roomba would, following a move, be in a position where it would be in collision with the supplied or indicated furniture item. Okay, so we're going to say public Boolean collision on move, just collision, Roomba move, RM, furniture, F. Okay. So we're making some assumptions here, so we're going to say that the functionality of the method is predicated on two assumptions, which is that there are no collisions on the path, so no collisions on the way to this furniture, and also that there are no difficult parts to our furniture, so there isn't any differences in height which might not cause a collision to occur. We're going to assume that all furniture entirely fills its footprint. So you can imagine a sofa, for example, would completely fill its footprint. There'd be no way that, at least usually, there'd be no way that the Roomba could somehow be within the same rectangle as the sofa and not be in collision with it. Okay, so we're going to make these basic assumptions. So the first thing that we need to do is we need to somehow extract the relevant information from Roomba move. Okay, so this method expects to receive a Roomba move object and a furniture object. Okay, but we need some way of extracting the relevant information. Okay, and what we're going to do is we're going to therefore call another method. So I'm going to make a new method and I'm going to call it public Boolean in collision. Okay, and rather than accepting a Roomba move and a piece of furniture, this method is going to accept slightly more detailed information. So it's going to accept an X position and a Y position, and it's therefore going to accept, and then it's going to accept a piece of furniture. Okay. So I'm doing this because I'm relying on Roomba move, which is nice because it neatly encapsulates and contains a potential move. But at the same time, that means that I have to do this extra step, which is to extract the relevant information. Okay. So I'm actually not going to answer the question of is there a collision inside the collision method directly. I'm actually going to return the result of a different method. Okay, and by doing that, I'm able to extract some information from Roomba move. Okay, so I'm going to say in collision, I'm going to do rm dot get x, and I'm going to do rm dot get y, and then I'm also going to pass through to this new method the piece of furniture that was originally supplied to this method. Okay, so taking the information that's supplied to this method, I'm going to extract information about the Roomba's move and I'm going to pass it to this in collision method. Okay. Obviously, there's another reason we have to do this, which is the result of a Roomba move is not just the move itself, it's the impact of that move upon the current location of the Roomba. Okay. So we don't want to know, is this in collision with just the values that are directly inside Roomba move. We want to know, is it collision when the current values are updated with the change in both X and Y location that are indicated by the Roomba move. Okay, so we need to say, is the Roomba going to be in collision when the current X position plus the movement and the current Y position plus the movement occur, so where the Roomba is now, plus where it might be on the x-axis in the future, plus where the, and then again where the Roomba is now on the y-axis, plus where it might be in the future. After this potential move, this is what this is describing effectively as a potential move, is there going to be a collision? Okay, and I'm now going to take all this information after handily extracting it and pass it to a separate method which I'm going to call in collision. Okay. Now, because this is sort of what we might call a utility method, we would be within our right, I guess, to make this private. Okay, so at the moment there's no reason for anyone to call this method from outside our class, so we would be well within our right to make this private. But just for ease at the moment, I'm going to keep it public. Okay, so because this is just a utility method that we're actually only at the moment calling from inside our own class, we would be within our right to make this private at this stage. Okay, so this is private methods is perhaps something you've not seen before. These are methods which purely support the operation of existing public methods in a class. Okay, so in collision here would support the operation of collision. So we would be within our right to make it private. Okay. So let's look at the in-collision method, which actually I think corresponds to the most complexity in this lab sheet. Okay, so let's think about all the possible scenarios in which a collision could take place given an x position, given a y position, which would be potential new positions of the Roomba, and given a piece of furniture. Okay, so let's think about first of all when collision has not taken place. Okay, so there are four main situations in which a collision will not have taken place when a Roomba's at a new x and a new y position, and when a piece of furniture has an x and a y position. Okay, the first is that a Roomba is to the left of a piece of furniture. Okay, and we know that a Roomba is to the left of a piece of furniture if the x position of the Roomba, so the center of the Roomba, plus the radius, so plus the distance to the outer edge which is closest to the furniture, if that is less than the furniture's x position on the left-hand side, so either at corners 0 or 1. So remember, corners 0 and 1 have the same x position, so what we effectively want to know is the center of the Roomba plus the radius, so this point here, as I've indicated, is this further left, is this less than the x position of either corners 0 or 1? Okay, so because they have the same x location, it doesn't matter which one I choose. So at the moment I'm just going to choose corner 0, because remember this is the consistent bottom left hand corner that we're using. So we want to say, is the position of the Roomba, is it further left than effectively the left edge of the furniture? If it is, or if it's the same, then we know it's either less than or just touching the piece of furniture, so there is no collision. Okay, so let's think about how to model this. What I'm actually going to do, just so the code is readable, is I'm now definitely going to use a private method. And what I'm going to ask this method to tell me is, given an x position and a y position and a piece of furniture, is the Roomba, or the new location of the Roomba, will it move it so that it's at a valid position, so it's left of the furniture and not in collision with it? Okay, so I'm going to say private boolean left of furniture. I'm going to give it the same information that was in my in collision method, the x pos, the y pos, and this piece of furniture. Okay. Actually, as you can see, there's really no need for me to have y pos in there, because at the moment I'm only manipulating values with the x pos, so we don't actually need to pass the y position through. Okay, so there's no requirement to pass everything that's given to a method through. I can simply just pass in the values that I want. Okay, so I'm going to say if left of furniture, yeah, I'm going to pass through the x position and the piece of furniture. Okay, then I'm going to say return false. Okay, so I know for certain if my Roomba is to the left of my furniture, then there is no collision, so I'm happy to return false. Okay, and let's at the bottom let's just assume that if nothing is satisfied, then I'm going to return false. Okay, so let's just put this temporary return false down here, because obviously Eclipse was complaining because you always have to have a return statement, especially if you have conditionals. Okay, so now I need to think about achieving the achieving the system that I talked about before, where I want to see if a Roomba is left of a piece of furniture. It's actually reasonably simple. So I simply take the current X position of the Roomba, I add the Roomba's radius, and then I want to see, is it less than or equal to the furniture's left-hand side, okay? So now remember I have a choice. I could effectively write 0 or 1 here because the values on the x-axis are the same, but I've chosen 0. So what this is effectively saying is the right-hand side of the Roomba, which is obviously the x position plus the radius, is that right position either less than or just touching the left-hand side of the furniture? If it's less than it, then we know that it is left of the furniture, so this method will return true. If it's true, if the result of this method is true, then I return false. Okay, so let me say that again. This will ask this method left of furniture, it will give it an x position, it will give it a piece of furniture, it will ask it, if the Roomba were to move to this x position, would it be to the left of the piece of furniture? Okay, this method tests that. It says, would it be to the left of the piece of furniture? If it would be, then it returns true, so I know that this if statement is satisfied. I then therefore go inside this conditional statement, I return false. Okay, so if the result of left of furniture is true, then the Roomba would not be in collision, so I can return false from this method overall. Okay. So I've now got to check that my Roomba is left of the piece of furniture, which is a positive check, which checks that my Roomba is not in collision. So I can go ahead and I can repeat this for all the other situations in which a Roomba is not in collision, which include the Roomba being to the right of the piece of furniture, the Roomba being at the bottom of a piece of furniture, and the Roomba being at the top of a piece of furniture. Okay, so again, just for brevity, I'm going to go ahead and I'm going to actually, by the magic of screen capture, I'm going to go ahead and I'm going to paste these things in. So you can see here that I have 3 more checks. I want to check, is my Roomba now to the right of the furniture? So instead of actually adding the radius on, as I did in left of furniture, I now minus the radius. So I want to say, is this point here, is this greater than the right-hand side of the furniture? Okay, so again, I have flexibility in terms of which corner I call to find the right-hand side of the furniture. So it could be 3 or 2, but again, I've chosen 3. So I want to say, is the Roomba, is this point that's indicated by the x position minus the radius, is this greater than the right-hand side of the furniture? If it is, then I know that there is no collision. Okay, and it's the exact same concept for being below the furniture. So again, rather than taking the x position plus the radius, I'm going to take the y position of the radius, the y position plus the radius, sorry, and I'm going to see, is this less than the furniture's bottom edge, okay, which again I could call through 0 or 3, but I've chosen to use 0. And then lastly, is the Roomba above my piece of furniture? If it is, then again, I want to identify this point, so the bottom edge of the Roomba, I'm going to say, is that greater than the top edge of the furniture? Again, this could be point 1 or 2, but again, I've chosen point 1. Okay, so very straightforward. Now, note that I want this could very easily be done inside the in-collision method. Okay, I have gone a bit overkill here in terms of providing these methods, but I just think it's nice to label each part of functionality, so to label what everything does, so that I can neatly see when I come back to this code in the future, I can see exactly what's going on. Okay, so obviously I now need to use these methods. I've made them private. I don't really expect to be using these for sure anywhere outside this class, so I can make them private. They're purely going to support the operation of the in-collision method. Okay, so I'm going to say if the Roomba's potential new position is left of the furniture, or if it's right of the furniture, so I'm going to give it the xpos and the furniture again. Okay, then obviously I know there's no collision, so I can return false. And just for neatness, obviously I could do this all in one conditional statement, but just to again logically separate the checks that I'm doing, I'm going to do a check for below furniture. I'm going to pass it the y position and the furniture, and I'm going to say above furniture, I'm going to pass it the y position and the furniture. Okay, and again in these 2 instances, I know that I could just return false. I'm sure you can see, as I've said, that I could do this all in one conditional statement. I could just have a series of ORs, not just 2. I could have 4 in a row. But again, I just want to remind myself when I come back to this code in the future that I'm doing 2 separate checks. One for that the Roomba's left of the furniture, one along the x axis, and one along the y axis. Okay. Now, I've done some sort of what we could call, as I've referred to, as positive checks here to check that there isn't a collision. It's now important that I work out when there is a collision. Okay, so if I'm checking for a collision and I pass these two statements, okay, so I know that the Roomba isn't left of my furniture, I know it isn't right of it, I know it isn't below it, and I know it isn't above it. So if I'm able to get through these statements without exiting the method, because of course remember when you hit a return statement, you do not proceed with anything that's below it, you simply exit the method and return that value. If I know I reach this point here, then I know that my Roomba must be somewhere in collision with the object, and it's just important for me to work out for sure where that is. Okay, so the first thing I'm going to ask myself is the Roomba on the same x level? Is it in line on the x-axis with the piece of furniture? Okay, because if it is, then it must be in collision. Okay, because we can see here from this small diagram, I've identified what I call as these collision zones. So here's one collision zone. So if the Roomba is anywhere along this line, if the center of the Roomba, if the x location is anywhere along this line, then because it's not entirely below the furniture or entirely above it, then I know that a collision must have occurred. Okay, so if it's anywhere along this line, I know it's along the same in the same x region as the piece of furniture. So between these 2 points, it occupies the same. This dot here occupies the center of the Roomba occupies the same x region as the piece of furniture. So I know a collision must have occurred. Okay, so what I want is some kind of method, some kind of way of checking whether my Roomba is in line with a piece of furniture. Okay, so again, I'm going to supply a nice utility method that's going to tell me this. I'm going to create a method called inline furniture x. Okay, it's going to accept a potential x position. It's going to accept a piece of furniture, and it's going to tell me, is that x position within this space? Okay, so is it within in the same x region as the piece of furniture? Because if it is, then as I say, we know it's not below, we know it's not above, so it must be in collision. Okay, if it occupies that same space. Okay, so I'm going to return very simply. I'm going to say, is the x position or the new potential x position, is it greater than corner 0? Okay, again, we could use corner 1 because we know we're just referring to the left-hand side of the object. And is the x position less than the furniture dot get x pos 3? Okay, so again, we could use 2 here because we're just thinking about the left and the right-hand side of the furniture. Okay, so let me say that again. Hopefully you can see from this diagram. So I know the Roomba isn't below because I've checked this already. I know the Roomba isn't fully above, so I know that if it occupies the same X region as the furniture, then there must be a collision along either the bottom or the top sides. Okay, so I know there must be a collision along either the bottom or the top sides. Okay, so I can express this by asking my program to work out for me, is the x position, is the center of the Roomba, is it in line on the x-axis with the furniture? If it is, then I know there must be a collision. Okay, so let's make this private. Again, it's just a utility method. We're going to make it return a Boolean so it can tell me this information. Okay, so I'm going to repeat this idea for the y-axis. So I'm going to ask, is the method in line on the y-axis? And again, for brevity, I'm going to skip forward a bit and I'm going to add this method in. As you can see here, the procedure is exactly the same. I want to find out, does my Roomba occupy the same Y region as the furniture? So this region that's indicated here. Is my Roomba anywhere within this region? Is the center of my Roomba anywhere within this region? Because if it is, and I know that it's not to the left of the object of the piece of furniture, and I know it's not entirely to the right of the piece of furniture, then I know that a collision must have occurred. Okay, so I know it's not directly to the left. I know it's not directly to the right because I've checked this already. So I know that a collision with one of these edges must have occurred. Okay, so I know that if I'm able to pass these checks and get to this point here in the program, then I know that if either of these methods returns true, then I know that there has been a collision. Okay, so here very simply for checking the Y position, we say, is the Roomba's Y position greater than 0? Again, this could have been 3 because they're on the same Y level. Is the Y position greater than than this side of the furniture, and is it less than the top of the furniture? So is Y position less than the top of the piece of furniture, which could be either corners 1 or 2. Okay, so occupying this region here, and again this could operate obviously on the right hand side as well. Okay, so here I can now simply say, because I've got these nice utility methods which are going to give me the information that I want, I can say if inline furniture X, I pass it the X position, I pass it the piece of furniture, or inline furniture Y, pass it the X position and the piece of furniture, then I know I can return true. Okay, so this works. Remember that these methods on their own, inline furniture X and inline furniture Y, won't tell me whether the Roomba is in collision. Okay, that's why these methods aren't called something like in collision with side. Okay, they don't tell me that by themselves. All they tell me is the Roomba in line with either the X region of the furniture or the Y region. Okay, if it is, and I haven't previously done this checks, as I say, this doesn't mean a collision has occurred. Okay, but if I'm able to get to this point in this method, I know I've already done these 2 checks, so I know that that a collision has occurred. Okay, now this is one of my main motivations for making these methods private. Okay, because outside of their use inside this method, they make very little sense. Okay, they only make sense in the context of this method. So I don't want other people to be able to call them. I only want to be able to call them internally because they only make sense to me. They're my own private utility methods. Okay. Our last check for a collision is going to be as follows. So we want to check now. We know when something is in collision with one of the edges. We now want to check, is there a collision with a corner? Okay, so as you can see from these diagrams, this doesn't take into account the fact that the center of the Roomba might be somewhere like here. So it might be in one of these bottom left region, this bottom left region, for example, or maybe the bottom right region, or maybe the top left or the top right region. Okay, so hopefully you can see that these checks, none of these checks see whether the center of the Roomba is in one of these corner regions. And in fact, you'd see here that inline furniture X, inline furniture Y would both return false, yet we know that there is a collision here. Okay, so we need one final check, which is actually going to tell us, are we in collision with one of the corners of the piece of furniture? Okay, now this is probably the most, relatively the most mathematically involved. What we actually want to check is we want to say, is the distance between the center of the Roomba and the corner, is this less than the Roomba's radius? Okay, so hopefully you can think back to I think maybe it was GCSE Pythagorean formula, if I can say that properly. It will actually tell us the length of this diagonal. Okay, so we want to know what's the distance between the center of the Roomba along a diagonal towards a corner, because obviously that's the distance that we're interested in. We want to know, what is this length? Okay, and if this length is obviously less than the radius, then we know that there's been a collision. Okay, so what we're trying to work out is, what is the diagonal distance from the center of the Roomba to one of the corners, to the closest corner? What is that distance? If it's less than the radius, then we know that we're in trouble and we have indeed made contact with one of the corners. Okay, so to help me out with this calculation, as I've said, I need to incorporate some Pythagoras, and I actually need to incorporate this standard distance formula, which you can see here, which subtracts a potential x position from the current x position, squares it and adds it to a potential y position minus the current y position, squares that too, adds them together, and then takes the square root. Okay, so this is a standard distance formula. This should maybe be familiar to some of you. We want to, for finding sort of the distance between 2 points on this 2D plane. Okay. So to help me out with this, because I know I might need to use distance in the future, what I'm actually going to do is I'm going to construct my own utility class. Okay, and I'm going to call this utility class geom for geometric, and I'm going to make my own static method, or my own reusable method, that's going to take some information and is effectively going to solve this formula. Okay. So I'm going to make it static because there's no reason for this class to have any state, okay? So if something is static, we assume that it's stateless. All it's going to do is it's going to take 2 values and it's going to make some kind of computation, and it's going to give me an answer back. Okay, so if you can see no logical reason why any information should be stored, then it's absolutely fine for methods to be static, which means that you obviously don't have to make an object of a class to access that method, and we'll see that in a moment. Okay, so as we've said in lectures, it is rare that you'll have to use static methods, but when you have to use repeatable functions like this that are doing some kind of calculation for you, these are the common times you'll get to use this. Okay, so let's construct a method that's going to effectively complete this formula. Let's construct a method where I can provide a current x and a y position, I can provide a second x and a y position, and I can find the distance on a 2D plane along a diagonal between them. Okay, so I'm going to call this method public as usual. The only difference, of course, is I'm going to call it static. Okay, the return type stays the same. I'm going to call it double, and I'm simply going to call this method distance. Okay, I'm going to have this method take 4 bits of information as per the formula shown. One's going to be the first point. One's going to be the first point's x. Second one's going to be the first point's y, and we're going to have the second point's x, and then we're going to have the second point's y. Okay. Now, this method I'm making is static, and it's performing some kind of calculation for me, but there are actually lots of existing methods that exist already inside Java that are going to do calculations for me. Okay, so I know I need to find the square root of something, don't I? And to do this in Java, we can actually access, as I say, someone else's static method, which is actually contained inside a class called math. Okay, so someone else has written exactly as we're doing here in our class geom. They've written a class that contains static methods and will perform some kind of calculations for us. Okay, so we're going to access what's called the math class. It's a standard library, so I don't need to import it. And if I do my .eclipse, will helpfully tell me all the different features that I have. And one of these is the square root function. Okay, so this function will very simply take whatever value you pass in there, and it will return the square root of that value. Okay, so sqrt, or square root, is a static method inside the math class. Okay, and the math class is just a class similar to geom that someone has written that exists already for us inside the Java library. Okay, which is nice and which is quite neat. Okay, another one of these static methods inside the math class is something called pow, okay, which actually accepts 2 pieces of information, as you'll be able to see from the Java doc, which is one value, and then it raises it to the power of the second. Okay, so I know here that I want to take x2 minus x1 and I want to square it. Okay, so what I can very simply do is, to the pow method, I can subtract 2x, I can subtract, 0.1x from 2x, and I can then raise it to the power of 2. Okay, so what that's effectively saying is, I know that I have this pow method, and I know that the first parameter is a value, the second parameter is the value that the first should be raised to according to the power. Okay, so I want to take this value and I want to raise it to the power 2. Okay, and I know that's how the pow method works from the documentation. Okay, so I do this calculation. I can then call pow again, because I know I want to add these 2 things together. I can do 0.2y, I'm going to do 0.1y, and I'm going to square it again. So the result of my operation is going to be, that should be a minus, is going to be, first of all I'm going to take the second point is x position minus the first point's x position. I'm going to square it. I'm going to add it to the second point's y position minus the first point's y position. I'm going to square it. I'm going to add these together, as you can see here. The brackets are always useful to work out what's going on. And I'm going to take the square root, okay, and then I'm simply going to return this from my method. Okay, so this now all works. This is now a nice, reusable static method that I've set up that's simply going to do some stateless calculation for me. It's not going to store anything anywhere. It's simply going to take these values, going to do some nice routine, and it's going to give me this information back. Okay. Now, such a static class might already exist somewhere in the Java libraries. I'd be very surprised if it didn't. But it's just nice to go through the exercise of writing these kind of static classes out. These kind of static methods out. Okay. So now I have access to this class. I can now go back and use it for something, which is nice. What I'm going to use it for is I'm going to use it for checking whether for the current X location and Y location of my Roomba, I want to check is there a collision with a given corner? Okay, so going back to Roomba, I'm going to make a new utility method. I'm going to call it contact with corner, let's say. Okay, I'm going to have it again, as always, return a boolean because I'm going to return true if there is contact with a corner. Okay, this time there's quite a lot of information to provide. First of all, I want to know the corner in question. I want to know as always, the new x position. I want to know the new y position of the Roomba, and I want to pass the a piece of furniture. And lastly, I want to pass obviously the radius of the Roomba. Okay. Now, we could pass radius here, but of course we know we're doing this inside Roomba. Inside the Roomba class, we know radius isn't really affected by the move, so we're actually well within our rights to remove this. Okay, so if you want to put radius in here, that's fine, but we can remove that for now. That won't affect our code at all. So we can remove radius from here, and we know the code will still work correctly because regardless of the potential move that takes place, the radius remains constant. Okay. So now, because I've got this nice snazzy utility method, I know that the work I have to do here is very, very minimal. Okay, so remember that the check I want to do is I want to say if a collision has occurred with a given corner. Let's first of all maybe assume that we're going to call the corner 0. Okay, so as is shown in the diagram here, then I know I can call contact with corner. Yeah, I supply corner 0. I supply the potential x position. I supply the potential y position, and I supply the furniture. Okay. And I know this is going to return to me whether the Roomba is in contact with corner 0. Okay, so I can simply here return true. Okay, so I know there's a collision if the Roomba is in contact with corner 0. So I can return true from my in collision method. Okay. So we can, as I say, we can now very quickly complete this. We just call geom. Okay, so let's look at how we call a static method. Rather than doing something like geom, my geom equals new geom like this, a static method allows us to simply write the name of the class. Okay, so we could write geom.distance, and I know here I can directly access this method without creating an object. You might think, well, this is lovely, this is nice and efficient, it seems faster. In general, no, you shouldn't be doing this. You should always be making objects of classes, because the reason I'm able to do it in a quicker way this time is because, as I keep saying, geom is stateless, so there's no fields inside geom, and usually, as you know, inside your classes you'll have fields. Now, you can't usually, or it's not good practice to have static methods if you expect there to be different things in fields. Okay, so you should usually just have instance methods, we call them. So methods that are only accessible by making an object of a class. So as I say, it's very rare that you'll have static methods in this way, but in this case it's logical to do so. Okay, so what's the information we need to supply? So first of all, we need our first x point is obviously our Roomba, so it's going to be xpos and ypos. So that's our first point, xpos, ypos. And obviously the second point is going to be the xpos and the ypos of corner of the 0th corner. So very simply we do furniture.getXpos. We know we're doing whatever corner's passed, so we know in this case it's going to be corner 0. And we can do exactly the same thing. Cheeky bit of copying and pasting. We can simply say get the ypos. Okay. So what this will do, if we go back to this diagram, is it will find the distance between the x position and the y position of the Roomba, and it will find the distance between this and the x position and the y position of whatever corner is supplied. In this case, we're only supplying corner 0. So as in this example here, it will find the distance between these 2 points. Okay. Then we need to ask, is this distance less than the radius? Okay. If it is, then we obviously know that the Roomba is in, or would be in, collision with the furniture, so we want to return this. Okay, so if it's less, the result of this, if this result is true, then we know there is a collision, so we can return this value straight from our method, and we know that there is indeed contact with the corner, so we can then go ahead and we can return true. Okay. The very last thing to do is obviously to check all corners. Okay, so it's not just sufficient to check corner 0, we need to check corners 0, 1, 2, and 3. Okay, and for this, obviously, as I've started writing, we just need a very, very simple for loop, which is going to take a value called corner. It's going to iterate through it up until 3, so while corner is less than 4. And rather than just simply checking whether the 0th corner is in contact with the Roomba, we're going to check a variable. So we're going to check 0, 1, 2, and 3. So we're going to check whether all these corners are in contact with the Roomba. Okay. So this is the bulk of the collision method, or the collision process done. Now note how I've put nice names on all my methods, so you can very easily go back and work out what's going on, exactly what we're checking. This is of course just one potential way to do this. I'm sure there are a number of different collision checks, perhaps more comprehensive checks they're doing, but this is one nice way that I think reasonably fulfills the requirement to check whether a Roomba is in contact with a piece of furniture. Okay. So let's start to wrap up by bringing all these things together. Okay. So the next thing we're going to do is we're going to define a room. Okay. We're going to very briefly define a room based upon, and we're going to use this room as the opportunity to bring together some of the objects that we've used already. Okay, so we can look back at the question sheet. We can say that now we need to define a class that represents one of Gwyneth's rooms. So a room will have dimensions and contain furniture. Okay, so straight away we know we need two fields. We're going to call them length and width, so we can correctly get the dimensions of Gwyneth's room, length and width. And now the more subtle part is that it contains furniture. Okay, so it suggests that a room is actually going to have more than one piece of furniture. What this should suggest to you straight away is that we actually need an array. Okay, so each room is going to contain an array of furniture. Okay, now remember, the beautiful thing about object orientation is that we can replace any normal data type with one of our own custom data types, which is what effectively classes are, custom data types. So we're used to doing things like int here, for example, which would say that I'm going to have this variable with multiple slots into which I can put many different integers. Well, we're well within our rights to write our own custom name here. So we're saying we're going to have this variable furniture, which is going to have multiple slots. And inside each of these slots is going to be an object of type furniture. Okay, so we're providing the ability to have multiple pieces of furniture inside a room. Okay. Let's think about a relevant constructor. Okay, so the initial requirement here is to assume there are exactly 3 pieces of furniture, but we're all very good programmers now, so we're not actually going to follow that. We're instead going to follow the alternative requirement, which is to say that we're going to generalize this so that we're going to actually give someone the opportunity to add as many pieces of furniture to a room as they like. Okay. Now, to do this, obviously, we need some kind of record of how many pieces of furniture they've chosen to add to a room. Okay, so we're going to provide a new field. Okay, and we're going to have a simple integer field, and we're going to call it items of furniture. Okay, what this is going to tell us is the current number of items of furniture in a room. Okay, so remember, if you go back to the notes on arrays, we saw that we had to maintain this counter. Okay, so here we're going to use this to store the current number of pieces of furniture inside the room. Okay, so this fulfills the requirement, or will fulfill the requirement, that we can have as many pieces of furniture as we want. And obviously we know that to do this we have to supply a very large size to our array. Okay, so let's put in a constructor. We're going to call it public room. We're going to have them specify double length, double width, and the final thing we're going to do is we're going to have an integer which is going to say max items of furniture. Okay, so by having the luxury of specifying as many pieces of furniture as they want, they also have to kind of give us some idea of how many pieces of furniture they're going to possibly want in the future. Okay, so for example, we can imagine someone would make an object of this room class. They'd know the dimensions of the room and they'd say, oh well, the most pieces of furniture I can have in here are 10. Okay, so they would tell us that the pieces of furniture that this room can contain is 10, but the actual items of furniture in the room, which is a separate variable here, would start at 0, and then as you added furniture in, would increase. Okay, so let's realize this. So we're going to simply say this dot length equals length, this dot width equals width. Okay, now we're going to create our array. Okay, so we're going to say furniture equals new furniture. Obviously, the size of our array is max items of furniture. Okay, and we're initially going to say this dot items of furniture is equal to 0. Okay, actually I don't need this items of furniture because there's no conflict here. As you'll have seen from the superheroes coursework, there's no conflict here, so there's no reason to use this. Okay. So items of furniture equals 0. Remember, there is a difference between max items of furniture and items of furniture. This is someone's estimation of the maximum number of pieces of furniture that can be in a room, while this simply tracks the current number of pieces of furniture in a room. Okay. So let's bring these ideas together to work out how to add a piece of furniture to a room. So I'm going to create a public method. Obviously, that doesn't really make sense. It doesn't make sense to pass anything back from this method. I'm going to call this add furniture. Okay. What this is going to accept is a piece of furniture, which I'm going to refer to as F. Okay. Now, what we want to do, obviously, is we want to take this piece of furniture and we want to add it to the room. How do we add it to the room? Well, we need to add it to the furniture array. Okay, so I want furniture. I'm going to have some index equals to F. Okay, so I want some index inside the furniture array. Obviously, it makes sense for this to be equal to items of furniture. So however many items of furniture there currently are in the room, we want to add the next piece of furniture into that index. Okay, so we're going to make sure that we're always adding into the next available slot in the array. Okay. Once I've added this, obviously I want to increment the items of furniture, don't I? So let's imagine that the room currently has no furniture in it, so there's no furniture inside the furniture array. That means that items of furniture is going to be equal to 0. So when I come down here, when someone wants to add their first piece of furniture, they're going to call the add furniture method. They'll supply a furniture object, and they will add this object into position 0 inside the furniture array, won't they? Because items of furniture is currently equal to 0. Okay. Once the adding of this object to the array has taken place, I then want to increment the number of items of furniture, don't I? So by doing this, I make sure that items of furniture always refers to the next empty position in the array. Okay. So this was something that was seen in lecture 3. This should be very familiar, but hopefully now you've seen it in a context, or in a particular context. So in the context of tracking these pieces of furniture, then you can see why it's useful. Okay. So let's move on to the next requirement, which asks us to make a Roomba run in a room. Okay. So what this means is we want to supply a Roomba move. So we want to assume that there's some Roomba in our room. We want to supply a Roomba move, and we want to see is there a collision with a piece of furniture? Okay, so obviously the first thing we need to specify is actually that we can actually add a Roomba to our room. So what we're going to do is we're going to have a field. We're going to have it of type Roomba, and we're going to call it vac. Okay, so obviously a Roomba is a vacuum, so we're going to call it vac. Okay, we're going to provide a method which is going to supply a way of adding a Roomba to a room. So add Roomba r. Okay, and what this is simply going to do is set vac to be equal to r. Okay, so what I've provided here is some way of adding a Roomba to a room. So we can imagine I could make a room object and I could add therefore my Roomba to a room. Okay, let's see this in action. So let's reopen our Gwyneth class and let's make a room. So let's create this. Let's create something that we're going to call Gwyneth's Zen room. Obviously she's a extremely spiritual individual. So we're going to create something called Gwyneth's Zen room, and we're going to create this Roomba object. Okay. Now it's nice to have some way to add the Roomba to the room, which obviously this is the capability we've already added. We've got this nice add Roomba method, so we can actually take this object and pass a copy of it inside Zen room. Okay, so this should be again a concept that's very familiar to you. It's very easy to pass objects into each other inside the superhero coursework or on the superhero coursework. You saw an example of this when objects are of the same type. So comparing two superheroes in the fight method, there's absolutely no reason you can't do this for different types. Okay, so that we know that inside our custom type room, inside our custom class room, we have a method called add Roomba, which accepts an object of type Roomba. Okay, so if inside my main method I have two of these objects, so one of type room and one of type Roomba, I'm well and fully able to call Zen room and then call add Roomba and then add the Roomba here. So I've effectively taken a copy of this Roomba object and passed a copy of it to Zen room. So this object now knows about this other object and can work with it and can manipulate it as necessary. Okay, so I've now effectively added a way to add a Roomba to a room. Okay. So now we can go ahead and we can answer this requirement, which is we now want to make it possible to run a Roomba in a room. What this will effectively mean is to move the Roomba or the instance of the Roomba object that currently exists inside a room, to move it. But obviously we only want to move it if we know that the move that's supplied is valid. Okay, so we've got all the pieces here. We know how to check whether a potential move is valid. We've just gone through the long process of checking whether a Roomba is in collision with a piece of furniture. All we need to do now is bring all these things together to work out, to allow someone to supply a potential Roomba move, and then to see, is this going to be valid at the end of the move? And if it isn't, then we don't let that move take place. Okay, so I'm going to go ahead and I'm going to add this method called run Roomba. So I'm going to make it Boolean. So remember, the requirement asks us to state we want to make it possible to run a Roomba in a room. So this suggests that we need to know when it's not possible. So it makes sense to make this method a Boolean. So remember, we had this method inside in the noughts and crosses example, where we would try and play a certain move, and we'd make the result of that method a Boolean, so we'd know when the play was not successful, so we could work with that response. In the case of noughts and crosses, that was to ask the user for a new move. Okay, so it's important that we're always returning relevant information. Okay, so I'm going to call this method run Roomba. It's going to accept a potential Roomba move, which I'm going to call RM. Okay, and now what I want to do is, for all the items of furniture that I have in my room, I want to check if the current Roomba with its, or the vac with its current location, if in the new location, if in the potential move, it's going to be in collision with a piece of furniture, then obviously I want to return false. I want to say that this run of the Roomba is not good, is not valid. Okay, so what I'm going to do is a simple for loop. I'm going to say for each item inside my furniture array, I'm going to say if the item is in collision with the Roomba given its new move, then I want to obviously return false. Okay, so I'm creating this index called item, which is going to loop up until items of furniture. So it's going to say, for each item of furniture, I want to see, is there a collision? So obviously I need to use item as an index into the furniture array. So this is going to obviously go, say for example, I had 3 pieces of furniture. It's going to go 0, 1, 2. So I will examine in turn each piece of furniture stored inside my furniture array. And what I want to do is I want to pass that information to the vacuum. So I want to say vac.collision, and I know from here, I know that collision accepts a Roomba move and a piece of furniture, which is the exact piece of information that I want to know, which is nice and handy. I'm going to pass it the Roomba move, which I know is RM, and I'm going to pass it each individual piece of furniture. Okay, so I'm going to go through and I'm going to see, for each piece of furniture, is the vacuum in collision with that furniture? Okay, hopefully you can see that by having this item index, it will allow me to extract each piece of furniture. It will combine that with the potential Roomba move. It will find, obviously it will go inside the Roomba class. It will find this collision method, this nice method that we went to great lengths to create before. It will extract the X and the Y from the move. It will add this on to the potential, to the existing X and the Y location of the Roomba. So it will work out where the Roomba will be in the future. It will compare where the Roomba will be in the future if the move were to take place with the relevant details from furniture. So effectively calling in collision, it will see, is it left of the furniture, is it right, is it above or below? If it isn't, then we know there is some type of collision and we want to determine what that type is. So we want to see, is it in line with the X position, is it in line with the Y position? And then we want to check each corner. Okay, so everything that we went through before. Okay, so for each piece of furniture, we want to call this in collision method, and we want to see, is the Roomba in collision with this furniture? So if vac collision. Okay, so we could say something like equal to true here, but obviously the shorthand for saying equal to true is actually just to omit this altogether. So Java will automatically check the logical result of this, and if it's equal to true, it will proceed with the if statement. So then we're going to say return false. Okay, so we're not going to allow any kind, assuming we have some vacuum, some Roomba that exists inside a given room, we're not going to allow the Roomba to move at all if we've pre-calculated that the given move is not valid. Okay, so this is a nice method now. If we're able to pre-calculate that the move is not valid, then we want to return false. Okay. If the move is valid, then we want to go ahead and make that move, of course. But at the moment, there's nothing inside Roomba that will allow me to actually do a move. It will let me move to somewhere. Obviously, I can see a new X position and a new Y position, but there's no way at the moment for me to actually make it do a move. Okay, so what I can do is add a very quick new method here that's a public void. I'm going to call it doMove. And rather than accepting an X position and a Y position, we're going to actually just make it accept a Roomba move, which I'm going to call RM. Okay. What I'm going to do is I'm going to update the X position and the Y position according to this move. Okay, so I'm not going to actually set the X position and the Y position as I did here. I'm actually just going to make it, I'm going to increment its position. Okay, so here, this would simply move it to a new location. Here, I actually want to increment its position. So the move of the Roomba is a sort of a continuous movement along the X and the Y, so in almost a diagonal motion. So this will allow me to move in a diagonal motion. So what I'm going to do is I'm not going to override the position, I'm going to just update it. So I'm going to take the existing X position and I'm going to add the X movement from the Roomba move to it. I'm going to take the existing Y position, I'm going to add the Y movement from the Roomba move to it. Okay. So hopefully you can see here, let's have some consistency here. I'm going to take the existing X position, I'm going to add the move to it. Okay. So now all that remains is when I want to run a Roomba in a room, I'm going to check whether there's any collisions. If there isn't, obviously I will proceed past this for loop. If I don't proceed past this for loop, hopefully you can see that I'm going to return false, so I will never reach this point. But if everything's fine, if there are no collisions, I will reach this point. At which point in time, what I simply want to do is I want to move the vacuum, as I've said. So I'm going to do vac. I'm going to do vac.doMove, and I'm going to pass it the Roomba move, which I now know is valid, and I'm going to return true. Okay, so I know that move has been successful. Okay. So to bring all this together, let's go back to our main method and let's add some furniture to our room. Okay, so previously I'd created this Zen room, I'd created a Roomba, and I'd added it to the room. Okay, now I'm going to create 3 pieces of furniture, like so. A meditation chamber, a study chair, and an incense table. They've obviously got their width and their length and their width, and their X and their Y positions. Okay, so that's all the relevant. Sorry, the other way around. The X position, the Y position, and their length and their width. That's all the relevant information. So now I have to go ahead and I'm going to add this furniture to my room. So I simply say zenroom.addFurniture. Now remember, this will go to the room class. It will find the addFurniture method. Remember, we've already established this scheme by which we can track how many items of furniture there are in a room and make sure that we're always entering the relevant item of furniture to the next available spot in the furniture array. So every time I call addFurniture, I'm going to add the supplied object to the next available position in the furniture array. So here, I create these furniture objects, and now I'm going to pass them inside Zen Room. So in the same way that I made a Roomba object, I was able to pass it inside the Zen Room and store it in one of the fields inside Zen Room using this method addRoomba, which would store this Roomba object inside this field here. I'm going to do the same thing for furniture, except rather than adding them into individual fields, I'm going to add them into different positions of an array field. Okay, so do make sure you're comfortable with this idea of how these objects can interact. It really is the reason that object-oriented programming is so neat. We can make these different objects, we can pass them into each other, and we can store them as we wish, and to really create very, very expressive programs. Okay, so I've created these pieces of furniture. I've created this room. I've added the furniture to the room. I've added the Roomba to the room. So now I can do something like zenroom.runRoomba. I could provide a new Roomba move, which will move my Roomba, say, along something like 2 and 2. So an increase of 2 in the X and 2 in the Y. So what will happen here is I could see, is this going to cause any collisions? So I do system.out.print, print line, the result of this Roomba move. I can then run my program, have a look at the output, and I can see false. Okay, so I actually know that there has been some collision that's occurred here. So I know if the Roomba started at 1, 1 and then moved 2 along and 2 up, that there will be a collision with some furniture. Okay, so I'm using the method here to work out whether this run is acceptable. If it isn't, then obviously the robot itself will know that it can't make this run. Okay. So a final little thing, just to neaten things up, just as the final little exercise, is to supply a method to check whether both the furniture and the vacuum are in relevant or correct positions in the room. Okay, so the first thing I'm going to do is I'm going to check when I've added, it's nice to say when I've added this Roomba to the room, it's nice to know, is it in a good position? Is it in a valid position? Okay, because obviously I shouldn't be able to add a Roomba to a room. I shouldn't be able to go on top of a piece of furniture, should it? I should have some way of knowing that it's in an open area in the room, on just on the floor. Okay, so what I'm going to do is I'm going to add another method. I'm going to call it valid vac. Okay, so I want the result of valid vac to be Boolean, so I'm going to say valid vac like this. And very, very simply, in the same way that I looped through my items of furniture in order to find whether the vacuum was in collision with a piece of furniture after a potential move, I want to find out if the vacuum is in collision currently. Okay, so what I want to do is I want to add a new method to my Roomba, which isn't going to find out if there's a collision from a potential move, but a collision currently. Okay, and now because of the nice methods that I have already, because of the way I've split the functionality of collision between these two methods, collision and in collision, I could do this quite easily. So I can define a new method called public boolean. Could call it something like current collision. And rather than passing a Roomba move, all I want to pass it is a piece of furniture. Okay, so I don't want to, as I say, I don't want to think about a collision with a potential move. I want to think about a collision right now. So I want to say right now, is this Roomba in collision with a piece of furniture? So again, I'm going to call the in collision method, but this time, rather than adding on anything like a potential move in the X and a potential move in the Y, I'm just going to pass the current X position and the current Y position and the piece of furniture that's been supplied previously. Okay, so this is a nice example of why it's good to split functionality like this. So I know that I've got this general method called in collision which accepts an X position and a Y position, but I don't know where this X position and this Y position is necessarily going to come from. Okay, so I've not tied down the functionality of this method to always consider the X position and the Y position or of the current X and Y of the Roomba, but instead any potential X and Y position. Okay, so this allows me to both check potential positions and also the current position. Okay, so now it's very simply a case of asking, is the vac, does it have a current collision with this piece of furniture? So I can just nick this from up here and I can check this. I can say if the vacuum is in collision with any piece of furniture currently, and I know this is not a valid position for my vacuum, so I can say if this, and I can return false. Okay, so very, very simple check. Is there a collision currently between the vacuum and a piece of furniture? If there isn't, return false. Otherwise, we're going to go ahead and we're going to return true. Okay. So the next requirement asks me to do the same or do a similar sort of thing, but for the furniture. So I want to say, is the furniture, I want to say two things about the furniture. First of all, I want to say, is it in the room? So obviously it's not good if you try and put furniture at a length or a width that is greater than the size of the room, or indeed in negative space, so not inside the room as well. And it's also good to check whether any pieces of furniture are in contact with others. Okay, so we don't want to stack things on top of each other. When we add our furniture to the room, we want to check, is it in valid locations? Okay. So let's do the simple check first. Let's check whether the furniture is inside the room. Okay, so as always, we're going to use a nice for loop. So let's define a quick method. So boolean valid furniture. We're going to say for each piece of furniture. So we obviously want to go through each piece. Okay, what we want to say is, is any one of the corners of this piece of furniture, is any one of these corners not inside the room? Okay, so This is quite a neat check, because in order for a piece of furniture not to be valid, it doesn't have to just be entirely outside the room. All that it requires is for one corner of that furniture to not be inside the room, and we know it's not a valid position. Okay, so we actually need a nested loop. So we need to go through, as you've seen before, go through each of the corners, and we need to say, is that corner inside the room? Okay, and we need to do this for both the X position and the Y position. Okay, so we're going to take a temporary variable called X. It's going to be of type double. We're going to go inside the current piece of furniture. So remember, the item here will provide an index into the furniture, and we'll extract each piece of furniture. And what we're going to do therefore is then going to take the X position of the current corner, and we're going to check, is this inside the room? So we're going to say if X is less than 0 or X is greater than width. So remember, we're inside room, so we're within our right to just access the width field directly. We're going to return false. Okay. So what this is going to do is it's going to go, as hopefully you can see, it's going to go through each piece of furniture inside the outer loop. It's going to examine each piece of furniture. How is it going to do this? Well, it's going to have this item index. It's going to use this inside the furniture array. It's going to, for each piece of furniture, it's going to loop again. It's going to go through each corner of that piece of furniture. So we're going to get the X position of each corner, and we're going to say, is the X position of each corner of each piece of furniture, so the X position of every corner of every piece of furniture, is it less than 0? If it is, we know that that corner is outside the room. Or is it greater than the width? If it is, then we also know that corner is outside the room. Okay, so we're being very thorough, but it's quite straightforward. We're just going to check every single corner, and we're going to say, is it inside the room or is it outside the room? What qualifies being inside or outside the room? Well, the Y position of a corner has to be greater than 0, and a Y position of a corner has to be less than length. If either of these conditions are not true, so the opposite is here, then we're going to return false, and we know that the furniture is not valid. Okay. The next thing to do is slightly more subtle. We have to check if the furniture is overlapping. Okay, so to do this, we're going to have to add a new method inside our furniture class. Okay, so what I'm going to do is I'm going to define this method, which I'm going to call overlaps. So I'm going to call it public boolean. As always, we're returning booleans. You'll see lots of booleans, and if the idea of returning a boolean value from a method is strange to you, let me know. We can talk about it further. But it's effectively, we know that these methods are all testing something, and we know that they're either going to return a true or a false value. Okay. So again, you should be now very familiar with the idea of passing classes of the same type into each other. So we're going to, obviously, to test whether one piece of furniture overlaps another, we need to pass a piece of furniture to it. So we're going to say, is this current, where whichever current object is represented, we're going to compare it to a different object. What we actually need to check is reasonably subtle. We basically want to check, is the right-hand edge of a piece of furniture, is it less than the left-hand edge of another? Okay. We know that if it isn't, then there's likely to be a collision, or if it is, we know that it's clear. Okay, so we want to say, is the right-hand edge of a piece of furniture, is it to the left of the left-hand edge of a piece of furniture, as you can see in this diagram. Okay, so as always, to help me, I'm going to define a nice utility method. I'm going to call it private boolean overlaps X. Okay, it's going to accept a piece of furniture in the same way that overlaps did. I'm going to call it furniture again. Okay. And what it's going to say is, do these overlap? Okay, and what we're trying to do here is we're trying to do a positive check. So we're trying to say, if there's no overlapping on the X, and there's no overlapping on the Y, then we know that this piece of furniture, that they're not on top of each other. Okay. So to do this, we're simply going to say, if get xpos, so of the current piece of furniture, 3, so we know that we can either use 3 or 2 here. Of course, we're just comparing the right-hand edge of the piece of furniture. If this is less than or equal to the other piece of furniture's left edge, so this could of course be 0 or 1, yeah, or the other way around. So if the rightmost edge of the other piece of furniture is less than the leftmost edge of this piece of furniture, then we know, of course, that there's no overlapping on the x. So if furniture.get xpos 3 less than or equal to get xpos 0. Okay, then we can return false. Okay, so hopefully it's clear here. Ooh, let me just put this on a different line so we can see what's going on. Hopefully it's clear here that we're comparing, as you can see from the picture, we're comparing the rightmost edge of the current piece of furniture to the leftmost edge of the other piece of furniture. We're seeing, is this less? Okay, if it is, or the other way around, so if the other piece of furniture's rightmost edge is less than this piece of furniture's leftmost edge, then we know that there's no overlapping there. Okay. Otherwise, of course, we're going to return true. Okay. Now we're going to do the exact same thing for the y. So we're going to say, effectively trying to see is one piece of furniture above the other or below the other, and we're going to check exactly the same thing. So we're going to say, is the top of one piece of furniture, so the current piece of furniture, below the bottom of the other piece of furniture? So is this piece of furniture below another, or the other way around? So is the other piece of furniture below the current piece? If it is, then we know that overlaps y is also not true, so we return false, and otherwise we of course return true because we know there's an overlap. Okay. So now what we need to do is to use these methods, to use these utility methods that we've created, overlaps x and overlaps y, to actually do an overall check for whether one piece of furniture overlaps with another. Okay. So to do this, obviously, we don't need to check that both on both axes overlapping doesn't occur. We only need to check one. Okay, so let's imagine these different scenarios shown here. So here there's an overlap on the x but not on the y, and this is perfectly fine. And here there's an overlap on the y but not on the x, and this is also perfectly fine. Okay, so to fulfill this, we're going to say something like, if not overlaps x furniture, or not overlaps y furniture. So we're not using an and here because that would be too strict to check, because remember, in these two scenarios there is an overlap on one axis but not having an overlap on the other is fine, because still this will fulfill these two possible scenarios. Okay, so in this case, obviously, we're going to return false, so there's no overlapping here, and otherwise, as we've done before, we're going to return true. Okay, so now we've got this nice overlaps method which we can use, and now it's simply a case of going through each piece of furniture inside our valid furniture method and checking whether it overlaps with another. Okay, so remember, we've already got this loop which will go through each item of furniture. So for each item, so inside this loop, we need to do another loop which will go through furniture as well. So we need a nested double loop which will effectively compare each item of furniture to another. Okay, so what I'm going to do, again, wonderful copy and paste brevity, is take this existing code that I've written. So we're going to say, inside this main items of furniture loop, I'm going to start another items of furniture loop, this time with a different index called other item. I'm going to make this start from the current item plus 1. Okay, so this is just to make it a bit more efficient. So rather than comparing pieces of furniture that have already been compared, I'm going to compare the current piece of furniture to the next one in the list. Okay, so obviously everything that's previously in the list has already been compared, so I'm going to compare it to the next item in the list. Okay, so I'm going to take the current item, I'm going to compare it with the next item. Okay, and then very simply I can just use the method that I've already used to take the current item, so from the outer loop here item, and compare it to a different item, so the next item in the list from the inner loop here. Okay, so one main outer loop that's looping through pieces of furniture, a second inner loop which is also looping through pieces of furniture. It starts with a given offset to retain efficiency, so I'm not double checking things, I'm only checking things once, because obviously if I've checked everything in the list before, there's no need to start from the very start of the array. I can actually just check from the item plus 1. Okay, so I do this check for all the items, and if at any point I find that something overlaps another, then I know this furniture isn't valid, so I can immediately therefore return false, which will quit the loop and return false from valid furniture. Okay, so the very, very, very final step is to add one final method which brings this all together, which I'm going to call valid room. Okay, and this is going to return valid furniture and valid vac. Okay, so this is now one master method, so to speak, which is going to call these sub methods valid furniture and valid vac. It's going to give me a means inside room to compare. To understand whether my room is valid, which means whether my furniture is in the right place and whether my Roomba is in the right place. Okay, so I could do something like system.out.println zen room is valid, or what did I call it? Oh dear. Valid room. I called it valid room. So to check valid room. Okay, so this will tell me if the Zen room is valid in terms of the position of my Roomba and in terms of the overlapping furniture. Okay, so I know if I go to my console here, I can see that no. So my assumption here would be that the Roomba is on top of something. Okay, so either that or the furniture is overlapping. Okay, so the next requirement asks you to write a program that creates room objects, so furniture, and creates a room and checks everything that's valid. We've actually been doing this as we go along, so we've already completed that requirement. Okay, so this brings me to the end of what I want to talk about in terms of Roomba. There is more to be done. There is more complex things in terms of working out how to run a Roomba in a room, making sure that it's got a valid path. But I think for this level, this point in your understanding, that this is enough. Look upon things like running the Roomba as extra credit. So, and indeed, I want to try and kind of test many of these principles in the next piece of coursework. So the idea of passing objects into one another, having multiple objects, the idea of a bit of geometry. These are things that I want to be testing in the next piece of coursework. So do make sure you go through these solutions and do make sure that you're kind of okay with what's going on, and get in contact with me if any of this doesn't make sense. Okay. Thank you. As always, I hope this has been helpful for you.